Hello friends, it's Mr. Williams. Today we're going to look at another problem involving estimation, arrays, 3x1 division, and remainders. All of the above. This is definitely a multi-step problem like you might see on your unit test next week. So please pay attention. A jewelry store has a display case for rings. It says they have 165 rings to display in the case. So they have a total of 165 rings. I'm thinking that's important information. It says 9 rings will fit in each column of the display case. Okay, so we have 165 rings. We can fit 9 rings per column. And then anything that's left over will be displayed at the front of the store as rings of the month. Okay. All right, so I know I have 165 total, and 9 will fit in each column. The first question says create an array to represent the number of columns of rings that will fit in the display case. If we can fit 9 rings per column, and we have 165 rings total, how many columns will fit in the display case? All right, well, let's talk about it. Well, actually, first, let's pause the video and give you some time to try this on your own. Okay, hopefully you've had a chance to work through this. The first thing I'm going to do is I'm going to use this strategy we call estimation. I think it's going to help me get close to where I need to be. I know I've got to get to 165, and I know that 9 rings will fit in each column. I got to figure out how many columns will fit in the display case. Well, I know I'm going to work with numbers that I'm comfortable with. I know that 9 rings times 10 equals 90. Okay, that's not quite 165. We got a ways to go, but let's go a little higher. Let's go with another number that we can work with pretty easily. 9 times 20 equals 180. Okay, because 9 times 2 is 18, and then we add the 0, we have 180. So our answer is going to be somewhere between, we know that 165 is between 90 and 180, but we know that 165 is closer to 180. So our answer to this question, how many columns will fit in the display case, is going to be closer to 180 than to 90. Well, I'm just going to go a little further. I'm just going to split the difference, and I'm going to go, what is 15 times 9? Go, what is 15 times 9? 135. 9 times 5 is 45. Put my 5 in the ones place, carry 4 tens. 9 times 1 plus 4 is 13. So I know that 15 columns will take up 135 of my rings, of my 165 rings. Well, I'm going to go ahead and I'm just going to create, we're going to make this gold because these are rings. They're gold rings, presumably. So we're going to go ahead and make 15 columns. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, if we have 9 rings in each of those columns, which we know 9 rings fit in there, and we have 15 columns, then we have 135 rings represented. Well, how many do we have left over? That would be the question I would ask next. 165 minus 135, you could probably pretty quickly tell is 30. We have 30 rings left over. Now I'm just going to be thinking about my multiples of 9. So I know 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. And 9 times 4 is 36. Well, this doesn't work. This is too low, and that's way too low. So I know that this is times 3. 9 times 3. 9 times 3 equals 27. So that means I can add 3 more columns of 9 rings to my display case. 1, 2, 2, 3. So I have 18 columns right now, and I have taken up a total of 20 minus 27, 3. I have 3 left. I'm going to represent these 3 in red. 1, 2, 3. Those are my remainders. If each of these columns, these gold columns, contains 9 rings, I can fit how many in the display case? Well, if you said 162, you are correct, because 18 columns times 9 rings in each column gives us 162. Remember, we had 165 total, so we have 3 left over. Number 2, write an equation that represents the number of columns of rings that will display in the display case. Okay, well, should be pretty easy now. We know we have 165 total rings divided by 9 rings in each column, and that should tell us how many we can display in our display case. Or multiplication is the reverse. We go 165 equals blank times 9. Well, we've already figured this out. If we did our work correct, we should know that the answer to this question is 18 remainder 3, which means 18 of them actually fit in the display case. But let's try it out just to be sure that we are correct. So we're going to set this problem up as 9 divided by 165. 9 will go into 1. 9 won't go into 1, but 9 will go into 16 one time. We're going to multiply 1 times 9, and we're going to bring it down here and subtract it. 7. We bring our 5 down. 9 will go into 75. 8 times. 8 times 9 is 72. And we're left with 3. 18 remainder 3. How can we double check ourselves? If you said 18, we can multiply 18 times 9, and we should get 165. You are correct, and that does work. Number 3, explain the relationship between the array, the equation, and the problem situation. Pause the video, talk to your elbow partner, and I want you to talk about what you think the connection or the relationship that exists between the array, the equation, and the problem. All right, there's probably a multiple answers to this question. I wish I could hear what some of you came up with, but there isn't one right answer. There's not one wrong answer. If you said something like, these are just different ways to represent the same situation, then you would be correct. The array or strip diagrams, bar diagrams, area models, these type of strategies help us visualize the problem. They help us see. I can envision that this is my display case with my 18 rows of 9 rings, and then I have these 3 red rings here that are going to be on display. They help us visualize it. The algorithms help us solve the problem just using numbers, and the problem helps us put it into perspective It helps us understand what's happening. It makes it not just a problem, it makes it a situation to fix or to solve, which is ultimately why we do math in the first place. I hope you enjoyed the video. Good luck. See you later.